Okay, so for this lesson, we are discussing ratios and rates. When you hear the word ratio or rate, think fraction, guys. This is just another way to look at fractions. A ratio, somebody tell me what the definition of a ratio is.
Is a comparison of
two quantities using division.
Yeah, comparison of two quantities using division. When you hear that word division, think fraction. So there's three different ways you can write a ratio. You can write it as 3/4. There's your fraction. You can also write it as 3/4 or 3/4. These are the three different ways you can write ratios. The most common way, of course, is as a fraction. Okay? All right, tell me the definition of a rate.
Ratio of two quantities
With different units. So this is going to be when you're doing real life word problems, measurements specifically. You can have a rate of 60 miles per 2 hours. This is a rate. Okay? What is a unit rate?
a rate with a denominator of 1 is called a unit rate.
Yep. So a unit rate is basically taking your regular rate, like you see here, we have our regular rate, and simplifying it to where you have 1 on the bottom. So if I were to divide 60 by 2, what do I get?
1. 30 over 1.
30. So all I did was take my regular rate and simplify it so that it's over 1. When you hear unit rate, you always have to have the denominator as 1. When you hear rate, it doesn't have to be the denominator is 1. It just gives you a measurement of one measurement compared to another measurement. Okay, this is what you're going to be dealing with your whole lesson. All right, so let's move on to example 1. There are 45 males, and when I'm doing a word problem, as soon as I hear something, I write it down. So 45 males and 60 females in a subway car. The subway car travels at 2.5 miles in 5 minutes. So for A, it said find the ratio of males to females. So when you hear the ratio of males to females, you think males is on top of the fraction, females is on the bottom. So how many males are there?
There's 45.
So I'll put that on top. How many females are there?
60.
60. The last thing you have to do when you're doing a ratio is reduce. So divide both of these by 5. What do you get? Well, no, divide both by 15.
So you get 3 over 4.
Very good. So the ratio of males to females is 3/4.
Wait, just like that?
Just like that. And then for B, they said find the speed of the subway car. You see, when I heard it, I wrote the rate, right? They want the unit rate. When they tell you to find the speed, that is finding the unit rate. So I'm going to say 2.5 miles over 5 minutes, and I'm going to try and simplify that. So in order to simplify that, I take the bottom number and divide it into the top number.
2.5 divided by 5.
So it's 2.5 divided by 5.
0.5, right?
Yep, 0.5. So that's how many miles they went, and this is a unit rate. So in how many minutes?
0.5 over 1.
Over 1.
So that's the answer.
That's how fast they were going. Now there's another way you can write a unit rate. I could say 0.5 miles per minute. You can put that big slash. That's also a unit rate. Instead of writing the 1, I'm just writing the label. So 0.5 miles for 1 minute. Any questions? Cool? All right, let's look at example 2. Take a picture of this. All right, the table shows the amount of money you raise by walking for a charity. Find your unit rate in dollars per miles. So first of all, we need to look at this and see if we have a pattern. For every mile, how many miles do we go each time?
2.
Yep, so each time they measured it, we had walked 2 miles. Is there a constant increase of money per 2 miles? Yeah, each time we measured it, it was 24. So we could say our unit rate is the change in money, would be the top, over the change in distance. Because they're trying to find out how much you raise per mile. So you put the money on top, miles on bottom. Does that make sense? So each time we measured the money, how much was it?
24.
24. Each time we measured the distance, how much?
2.
So this is $24 over to what? 2 miles. So how do I change this to a unit rate?
Oh, you have to simplify.
Yep, simplify 24 over 2, which would be what?
12 over 1.
12 over 1. So I am making $12
A mile.
per mile. So there's the third way you can write a unit rate. Usually you'll only see that when you see money, because your label goes in front of the number. So for every mile I walk, I made $12. Pretty cool. Any questions on how we did that? You understand how to look at the table and see that there's a constant change, constant increase? That's important. All right, look at on your own number 1. Grab a piece of paper. In example 1 that we did, find the ratio of females to males. We'll go back to example 1. How many males did they say we have?
45.
And how many females did they say we have? So we need to find the ratio of females to males. So which number goes on top?
The 45?
Females to males. Which number goes on top?
Oh, the 60.
Yep, 60. The number you hear first is the one that goes on top. 60 over 45. Can I reduce that? What would I get?
12
4 over 3.
Yes. You divide both by 15. And you can reduce twice. So if you got 12 over, what would it be?
9.
9. You reduce it again. Divide both by 3. You'd still get 4 over 3. Good. All right. Number 2. In example 1, so we're still dealing with these males and females on the subway bus. Find the ratio of females to total passengers. So make sure, that means you have to add 45 and 60. But first, what's the number that goes on top?
60.
60, because we're doing females to total passengers. Total passengers, you would add 60 plus 45, which would be 105. Now, can I reduce that?
Yes.
Yes, they both end in a 5 or a 0, so you can always divide by 5 to start with. So 5 into 60 goes what?
12.
And then 5 into 105 goes, is it 21?
Yes, 20.
Now, can I simplify those? Yeah, you can divide both by 3. 12 divided by 3 is, and 21 divided by 3 is 7.
So there's no unit rate?
Not when you're dealing, not when you're dealing with, because it wants the ratio. If it were to ask you for the unit rate, you could find it, but they want the ratio. So when you're dealing with ratio, you just simplify as low as you can on the ratios. All right, on your own number 3. You don't have to put the table on your paper. I'm just putting it for instructional purposes. All right, so the table shows the distance that the International Space Station travels while orbiting Earth. Find the speed in miles per second. So when you hear that word second, it means we're going to find what? The rate or the unit rate?
The unit rate.
Unit rate, because it wants it by 1 second. So first of all, let's see if we have a consistent increase on these. What are these increasing each time?
3.
Yeah, this went up by 3, plus 3, plus 3. What about these ones?
14.4.
Plus, wow, that was a terrible plus.
I think it's
Plus 14.4 here. So what's 28.8 plus 14.4?
43.2.
I believe you are correct. Okay, so then each time it went up by 14.4. So they want to know, what would it ask? Miles per second. So what goes on top?
The distance.
Right, so I'm going to put 14.4 on top. And then time goes on the bottom, which is?
3.
Yep. 3 what?
Second.
3 seconds. Okay, now they want the unit rate, so I got to divide 14.4 by 3. So grab your calculator. Tell me what you got. It's a race. Who's going to do it? 14.4. 4.8. And then we have to label that. What would it be?
4.8
Miles per
second.
second. Very good. Awesome. Any questions? Not too bad, right? All right, let's do example 3. Grab your journals again. Okay, finding a rate from a line graph. So they've given you a graph, and we're discussing sound through water. So they're discussing how long it takes for sound to travel through water, and they've measured it with kilometers and seconds. So the graph shows the distance that sound travels. Find the speed of sound in kilometers per second. So are we finding the rate or unit rate?
The rate.
Kilometers per second.
Oh, unit rate.
Unit rate, because it's only 1 second. That's how you have to read it. So the first thing we do is we choose a point on the line. So if you look at this point here, you can see that sound travels how fast? How fast? We're talking about time first.
2 seconds and 3 kilometers.
2 seconds and 3 kilometers. So what am I looking for that goes on top?
The kilometers.
Kilometers. So I'm going to say 3 kilometers for every 2 seconds. Now, how would I make that a unit rate?
Divide?
3 divided by 2 is? 1.5. 3 divided by 2? It's 1.5. So 1.5 kilometers per what? Second. So is that my unit rate? Then you're done. Now, could I have found the same thing and used in this other point? Shall we find out? I would put kilometers, which was 6 over 4, right? Kilometers per second. What's 6 divided by 4?
3. 2.
6 divided by 4?
2.
Grab your calculator and do it.
5.
6 divided by 4.
1.5.
Still 1.5. So does it matter which point you choose?
No.
Not at all.
This is going to be simplified.
Yes, and here's how you know, guys. You see this line? It's a beautiful straight line. Not my yellow line, the one that they put in the book. Okay? If a line is ever doing this number,
It's gonna be the same.
no, the wiggly number, then you can't find a consistent rate.
If it's straight.
If it's a beautiful straight line like you see there, you're going to always be able to find a rate. So it doesn't matter which point you use, just pick one that's easy to find and solve it. All right, on your own number 4. What if, in example 3, oh, I just did that. I didn't know we were going to do it, and I did it. It says, what if, in example 3, you use the point 46 to find the speed? We already did it. Yep, so you would say, you can just write this down on your paper. That's funny that I didn't even know we were going to do that. Kilometers per, so this is what you need to write. Kilometers per second. And then why or why not? It is a constant, I can't spell constant. Constant straight line. Awesome.
Can you reduce 1 and 2?
How funny. All right, let's do number 5. The graph, I need to take a picture of.
How about 4?
That we just did 4.
Oh.
That's why I laughed, because we accidentally did 4 for fun when I went through the example, and then that was what you were supposed to do for the... All right, so the graph shows the distance that sound travels through air, much faster than through water. Find the speed of sound in kilometers per second. Okay, so how are we going to find the kilometers per second here?
Seconds of a kilometer.
Okay. So how do we find kilometers per second?
Oh, we have to look at the graph.
We pick one of the points, right? So which point do you want to use?
Or 1.
Does it matter which point we pick? No, because it's a constant straight line. So kilometers goes on top, so which one's kilometers? 1.4 kilometers over 4 seconds. Now I need to find the per second. So I need to find the unit rate. So I'm going to divide what?
The 4 to 1.
Into 1.4. So what's 1.4 divided by 4?
0.35.
Yep, 0.35. Label it what?
Kilometers.
Kilometers per second. Very good. All right, now number 6, I'm going to leave this here because 6 pertains to what we just did. Does sound travel faster in water or on air? Okay, well, the one we just did was what?
Air.
Air. So air was 3.5. I mean, sorry, 0.35. And what was water? We did that on example 3.
1.5.
That was 1.5. Which one of those is larger?
Water.
The water is larger. So does sound travel faster in water or in air?
In air.
No, it's in water. I thought it was faster in air. How funny.
Oh, because it has a...
We learned something.
We did learn something. So sound travels faster in water. Maybe that's why dolphins talk so well, and whales.
That's probably why they have good hearing.
Cool. Any questions?
How about what do we do for?
It's faster. I hate some of their explains. I'm just like, what do you mean explain? That one's faster than that one. So, all right, I did not assign any work out of the book for today. You need to just work on IXL J5.
Hey, you, Miss, I have a question.